Hello friends, Dr. Kazmi here, welcoming you on my YouTube channel. There is a big question floating around in minds of millions of people as why some people are getting COVID reinfections despite being vaccinated, some even 3 times, while others never had it despite some pretty decent exposure to the virus. So we will try to answer this question with the help of recent research. So let's get started. Now, the first thing is that there is another global surge of COVID infections these days, mostly caused by the BA.5 variant of the Omicron. Now, I will show you two images. The left image shows the recent UK infections, and the second on the right shows that how the variants have been juggling the surges in the past and the present. Now, focusing on the left, as you can see that between October 2021 and the end of June of this year, there have been two major surges in the UK and the numbers have been increasing. The first surge was somewhere in December and January, and the second surge started somewhere in March and April, and now we are seeing a third surge. So two surges in over the last, like I would say, 7-8 months, and now a third one is going. And if you look on the right image, you can see that it's mostly the BA.5 variant. So in the beginning, when the first, in the last 8-9 months, when the first wave started somewhere in the end of November and December, the main variant at that point in time was the BA.2 variant of the Omicron. Now, you can see as the Omicron BA.2 variant, it's startly vanishing. We had another variant which caused the March surge, and that was the BA.2. Sorry, the BA.1 caused the initial surge of the November, December, and the BA.2 caused the surge that we saw in the end March. And now we see that both BA.1 and BA.2 are almost going down, almost negligible, while the BA.4 and the BA.5 have risen. Especially the current infection is being driven by BA.5 variant, which they say is more transmissible as compared to the BA.1 and BA.2. And why it is more transmissible, why it is driving the recent wave of COVID infections, let's try to see why this is happening. So if I move on to the next slide, here you can see the antigenetic variation between the different variants of SARS-CoV-2, and this variation is from the original virus when it struck in late 2019. So if you look at this, the original SARS virus was somewhere in the middle, and then we had the Delta one, that the Delta variant that came somewhere in late 2020 and drove infections around the world. And if you see, the Delta variant was very close to the original one, so it was still close. And this actually, the more they are farther from the center, it means more antigenetic variations they have got. And I told you basically the antigenic variations is caused by the proteins which are there on the spike protein. So the spike protein itself on the surface of that is made up of different types of proteins, and the antibodies are formed against these proteins. So if these proteins they change, then obviously the antibodies can be fooled. So in the beginning, the Delta variant was not that much different in terms of antigenetic variation from the original one. Then we had the Omicron BA.1. So if you see the Omicron BA.1, which is here in the red in the right lower corner, that was quite different in terms of antigenetic makeup from the original virus. And then we had the BA.2 again, which was quite different in terms of antigenetic variations. But now if you see the BA.4 and the BA.5, they're almost outside of this box. So there have been a lot of antigenic changes in the spike protein. And obviously it makes it very difficult for the existing immunity, which is mostly against the Delta 1 or the BA.1, that it would be able to counter the proteins on the spike protein of this BA.5 variant, because you know that basically the antibodies which is formed against the spike proteins, they are based on adaptive immunity, and adaptive immunity comes in two forms. Either it comes in the form of vaccination, when you actively vaccinate someone and they develop antibodies against that particular type of protein that is injected in them, or it comes through the natural infection. So if somebody is naturally infected with COVID virus, so there are antibodies against that particular strain of the COVID virus. But whether these antibodies, which are formed as a result of vaccination or as a result of natural infection, whether they would be effective against future infections, depend very much on what would be the antigenic makeup of the future variants. And here we can see that the BA4 and especially the BA5 are farther, east to the what we call as the antigenetic makeup of the original SARS-CoV-2 virus, and therefore it is less likely that the antibodies which have been formed against the Delta or the BA1 or the original variant as a result of the natural infection or vaccination, they would be helpful, as far as the current BA5 variant is concerned. Now, if we look at these images, basically they come from Portugal and South Africa. And why I have included Portugal and South Africa in these things? Portugal has had a very high vaccination rate. Now, recent research has shown that adaptive immunity, whether it is in the form of vaccination or natural infection, is not giving enough protection against infection. And I'm using the word infection because still vaccines gives a protection against the severe forms of the disease. So vaccines are protecting against the severe forms of the disease, whether it's caused by BA4 or BA5 or any other variant, but it is not giving enough protection against the recent variants, the BA5. And but still we are seeing that in some cases the theory is also getting eroded. Anyhow, coming back to the images, Portugal right from the very beginning had very high vaccination rates. So if you look at the image on the left side, despite having very high vaccination rates, if you look, the blue shades is actually showing the current infection drive, and we can see that despite a very high community vaccination rate, there have been increase in infections and hospitalizations because of the BA5 variant of the Omicron. On the right side, you can see the graphs from South Africa. Now, South Africa had a very high antibody rates, 98%. It simply means that there was a lot of infection in the community. So antibodies come through natural infection. So South Africa had so many waves, so many people were affected. So I had a very high community infection rate and people developed antibodies. But despite having natural infections, even in South Africa, we are seeing an increase in infections caused by BA5 and also the hospitalizations caused by BA5. So it didn't matter whether the people were vaccinated or they were not vaccinated and they got the natural infection. In both cases, we are seeing that the infections are rising. And that again puts a question mark on the adaptive immunity. Initially, I told you adaptive immunity comes either through vaccination or through natural infection. But because of this antigenic variations in the new variants, most probably the existing immunity is not that effective in countering the new variants. So that's why thinking that we would be having vaccine against each and every variant that is coming is probably not going to work, because as long as the virus is circulating, it would definitely come up with new variants, and as new variants have got more and more antigenic changes in their proteins, probably immunity either in the form of vaccination or in the form of natural is not going to work. So again the focus would be shifted back to what we call as innate immunity, that is your natural immunity, which doesn't depend on the spike proteins or the antigenic structures of the pathogens that enter your body. The innate immunity, irrespective of that, whatever is the antigenic structure, is going to hit that. I'll come to that in a moment. But back to this slide is showing that adaptive immunity, either natural or vaccine mediated, is probably not working much, and whether there have been countries where there was high vaccination rate or where there was low vaccination rate and high infection rate, still they are seeing a rise in the BA5 variant of Omicron. Okay. Moving forward, this is showing that most of the world is seeing a surge in COVID infections because of the BA5 variant. Now, whether they are good or bad immunization coverage. So if you look at this chart, South Africa, Portugal, UK, Austria, Netherlands, France. I mean, all the European countries, many countries in the Asia, many countries in the African continent, they are seeing a surge in the BA5 Omicron variant infections, and that is irrespective of whether they had good vaccination coverage or bad vaccination coverage. So probably vaccines have not helped as far as the new variant are concerned. But again, I would put it down to uh, the fact that basically the infection rates are rising, but vaccination still protects you against the severe form of the disease. So having infection is one thing, dying of infection is another thing. So you normally somebody would die if they've got the severe form of the infections, and at least for that particular aspect, vaccines are effective. Though we are seeing that basically the vaccines are not that much effective in preventing the reinfections because of new variants. That is something which the science further needs to look into. So coming down to the $1,000,000 question, why these reinfections are occurring? Why some get it while others not? And for that we need to revisit our basic immunology knowledge. So looking at the diagram, so we've got two parts of our immune system. One is the innate immune system and the other is the adaptive immune system. The innate immune system basically depends on your white blood cells, especially your neutrophils, monocytes, and eosinophils. So in this, monocytes are very important. I mean, monocytes in the blood are known as monocytes, but once they enter the tissues, they are known as tissue macrophages, or in some cases as dendritic cells. Neutrophils, these macrophages and dendritic cells, they directly attack anything that is foreign to the body. So like if a virus enters, irrespective of whatever variant it has, these white blood cells, through their like cellular mechanism, they attack, and they use different chemicals to kill the viruses and the bacteria. And one of them is interferons. Alpha interferon and gamma interferon are very important chemicals released by this cells of the innate immune system in killing anything that is foreign, and it doesn't depend on their antigenic structure. While the adaptive immune system basically consists of your lymphocytes and the T lymphocytes, basically, and the B lymphocyte which produce antibodies. So the T cells, what they do is they look at the antigens, they process these antigens, and then they signal the B cells to produce antibodies against that. So these are very specialized. Adaptive means they adopt to the infection, they adopt to the virus. So whatever virus or whatever bacteria comes into the body, their antigenic structure is analyzed by these cells, and then specific antibodies are made which would only hit that particular variant. So it depends very much on the antigenic structure of the foreign pathogen that enters the body. So it would depend on that. So it's very much specific to particular types of the viruses and bacteria. While the innate immune system doesn't look at that. I mean, it would like blindly attack anything that is that. So obviously, antigenic structure doesn't matter to it, and the chemicals that matter, which has released these innate immune system, they are alpha and gamma interferon. There are a few other ones like tumor necrosis factors, some interleukins, but by and large, important are the gamma interferon. And recent research is also shedding some light on the role of the alpha and the gamma interferon, as we will see in the coming up slide. But it's the innate immune system which is very important. So if the innate immune system is strong, the variance doesn't matter, it's going to attack it. And let's see how it does that. So there has been researches on the role of innate immunity in COVID, and there was this one research which actually looked at the people who were affected by the SARS and MERS, and their interferon levels were also checked, and they found out that patients with severe SARS, that is severe acute respiratory syndrome, or the Middle Eastern respiratory syndrome, had high viral loads and delayed interferon responses. So those who had the severe, they had delayed interferon. So somehow interferon was either delayed or was low in quantity. Thus, it could be that patients most susceptible to severe disease are those that cannot mount an effectively early antiviral immune response. So they are talking that those people who get the severe infection, and most of them would die, like in case if it is not treated properly, these are the people who cannot produce an effective early an early immune response in the form of innate immunity, and the innate immunity consists of the white blood cells that I just mentioned, and they do it through the release of the type 1 interferon. And probably these were the guys who were not able to produce enough amounts of interferon which could fight the viruses. And they said type 1 and type 2 interferon responses were highest in patients with mild to moderate disease and were low in the patient with severe critical disease. So those who had mild disease, they found out in that the interferon levels were high. So like if the interferon levels were high, they were able to fight the bacteria and therefore got the mild form of the disease, while the other guys who had the low interferon level, they probably had the severe disease. And they said like patients with more severe disease had less type 1 interferon activity in the blood. This is what they concluded. So there is a role for type 1 interferon response, type 1 and type 2, and this gamma interferon is released by the cells of your innate immune system. So the innate immune system is weak or was weak in these particular cases. They had more severe disease. Somehow there's a protective role of gamma interferon because it just blindly attacks the viruses when they enter the body. So moving on to the next slide. Again, here in the graph form, it shows the interferon levels in those people who had different levels of severity of COVID infection. So if you look at the graph on the left side, you can see that the interferon alpha 2 levels were highest in those people who had the mild form of COVID, while those who had severe and especially the critical form of COVID infection, they had low levels of interferon alpha 2. And similarly, as far as the interferon alpha activity is concerned, I mean, as far as release is concerned, again, you can see that the activity was highest in those people who had the mild form of COVID infections, and it was quite low in those who had severe or critical or life-threatening forms of COVID. So this particularly shows that interferon is very important as far as the severity of COVID infections is concerned. So those who were able to mount a good interferon level or good interferon activity, they got the milder form of the illness, and those who were not able to do that for some reason, their interferon levels were not increasing, they had more severe or critical level of the illness. Okay. Then recent studies have also shed light on the role of sunlight. Now in 2021, they correlated the European countries' mean climatic temperatures. So they took a few European countries and their mean climatic monthly temperatures, their humidity, and global coordinates in the form of latitudes, like how north or south they were from the equator, and the rise of COVID infection in those particular countries. And the data was quite interesting. Like for example, if you look at these graphs, so when they looked at the correlation between the country mean temperature in Celsius centigrade and the dates at which they found out no correlation. So the line was almost like horizontal. They found like correlation coefficient was almost zero. So there was no correlation between the country temperature and the surges in the COVID infection. So whether the temperature was low or whether the temperature was high, in different countries the surges occurred. Similarly, when they looked at the humidity level in these countries and the rise in COVID infection, they found out no correlation between that, because different countries had different humidity levels, and at different humidity levels they got the surges. So again, they didn't found any correlation. But when it comes to latitude, that the degree that they are north or south of the equator, then they found out that there was more or less a linear relationship. Those countries who had low latitude, like they were like more close to the equator, they had less surges in the COVID infections as compared to those countries which are up further north. And the more they are close to the equator, more the sunlight hits those countries as compared to those which are not, because obviously then in the winters the days are shorter, less sunlight, and those countries which are close to the equator, they get more sunlight. So they found out that countries which were more north of the equator and obviously less sunlight, they had more COVID surges as compared to those countries which were close to the equator. And the European data, actually you can see that the correlation coefficient is plus 0.77, which shows a very not strong but moderate correlation between the latitude and the surge in the COVID infections, and this latitude basically determines how much sunlight the country gets. So there was definitely a role of sunlight in preventing the surges in infection, because sunlight brings warmth as well, and probably as well as it's got like sunlight also has got ultraviolet light, so that might also help. Anyhow, further research is needed into to look into the effect of these things on the COVID infections. Moving on to the next slide, when we talk about sunlight, there is also some evidence that warming the body core temperature has got an effect on mobilization and activation of the innate immune system. And this research, which is an old research which was done back in 2002, it looked at human monocyte stimulation by experimental whole body hyperthermia. So 12 volunteers, they were immersed in hot water bath that was 39.5 to 40 degrees Celsius, and then they found out how much was their monocyte activity, and they observed that after 3 hours of like putting them in this hot bath, the response of monocyte to endotoxin was enhanced in an ex vivo lipopolysaccharide stimulation assay, which was expressed by a greater alpha tumor necrosis factor release, which was statistically significant. So what they are trying to say here is that when the body core temperature rises because of putting them in hot water bath, and I think in certain cultures people talk about hot water baths and how they much are helpful, in fighting different infections. And maybe this is related to that as well, and it has been proven by research as well, that when the core temperature rises, the monocytes are activated to release the tumor necrosis factor alpha, which helps in fighting. And that's one of the reasons that we say that fever is a good thing, and it's like sort of a body's natural responses to fight infections. So this was another thing that they found out. Moving on to the next slide. Similarly, this sunlight also has a beneficial effect on containing COVID deaths, not infection death. And the study in the British Journal of Dermatology recently looked at sunlight exposure and COVID death across 3 countries, that were the United States of America, UK, England, and Italy. And they found out that those areas where there was more sunlight, the number of deaths was less as compared to those areas within these countries where the sunlight was less. So as you see that as the sunlight intensity increases, the number of deaths that decrease. So like there was an inverse relationship between the intensity of the sunlight and the COVID deaths. So the sunlight contains ultraviolet rays, and they say ultraviolet rays somehow are helpful in destroying the virus. So in this particular study, they concluded that given the fact that the effect appears independent of vitamin D pathway. And obviously, when we are talking about sunlight, it's not of related to vitamin D, though we know vitamin D also has got a protective role in COVID. But this pathway was independent of vitamin D, this like sunlight thing. And they say that somehow sunlight, it might be related to ultraviolet rays, was helpful in reducing the COVID deaths. So they say because this was an observational studies, it possibly suggests new COVID-19 therapies, but more research is needed to look into this particular issue. Now coming down to the role of the oxidative stresses, and this theory is that they say that many serious effects of COVID are through oxidative stress, because the angiotensin 2 receptor, which is ACE2 receptor, basically on that the angiotensin 2 is attaches, and this angiotensin 2 basically when it attaches to its receptor, it is converted to angiotensin 7, and that helps in making antioxidants. But when it is blocked by the virus, what happens is that it leads to free radical productions, which causes endothelial damage, and then this endothelial damage is responsible for complications like clotting, like stroke, renal failure. So the study found out that oxidative stress increases with age and was found to be more in patients infected with COVID. So they look at the different antioxidants like the glutathione, and they look at the markers of oxidative stress like F2 isoprostane, and they looked at as the age increases, the oxidative stress increases because less number of glutathione in the body cells, and that was more pronounced in patients who suffered with COVID infections. Okay, moving on to the next slide. So, to summarize it all, there are a few factors that determine if a person will get reinfected by COVID or not. So, innate immunity. How strong is the innate immunity? Because the innate immunity plays a part in because it doesn't depend on the antigenic structure. If it is able to mount an interferon response, it will contain infection in the very beginning, and the person will not get reinfected. The second is warming. So warming, if the body core temperature rises, whether they do it through the baths or whether they do it through anything, I mean the fever itself, that helps in getting rid of the infection. Third is the sunlight. We have seen that the sunlight, and this pathway is independent of vitamin D. Sun has ultraviolet rays or something. It helps in reducing the severity of disease, and research has shown that those areas which get more sunlight had less COVID deaths. Then vitamin D is already established fact that vitamin D acts as a trophic hormone basically, and helps in boosting your immune levels, and reduces the severity of the disease. And final is the oxidative stress. The less is the oxidative stress. That's why there might be a role for antioxidants like vitamin E and things like that, in order to boost your immunity and reduce your oxidative stress, and that also helps in reducing the severity of the infection. So that was all about COVID infections, why some people are getting it, why some are not getting it. I hope this clarifies this issue to some extent. If you still got some questions, put it down in the comment section below and I'll get back to you. Anyway, have a very good day. Take care. Bye bye.